Okay, Ade, please kindly make me co-host.
Am I the host?
I'll make you
Oh,
host.
all right. Um, okay. Good day, everyone. I, Niket, or Kuma. You can unmute yourself and exactly.
Hello.
Yes.
Hey,
Sorry,
good.
can you correctly pronounce your name?
Niket.
Niket. All right. Hi, Niket. Um, Welcome to the live coding session. And you seem to be the only participant here currently. So I've made an announcement on Slack, and hopefully more people will join us as okay, we have another person available. So we'll just start and then
Okay.
yeah.
Okay.
Can
Okay.
you confirm if you can see my screen? So can you
Yes,
just
it's
confirm?
visible.
Yes, thank you very
Yes.
much. Okay, so we are in stage B, and first I want to congratulate you all and anyone that will watch this after for making it to stage B. So it was not an easy ride. We have over 50% of our initial participants did not successfully scale through stage A. So it's very nice to have you guys on board, and it shows your dedication and the amount of knowledge, or even if not knowledge, skill and time you are willing to put in to come out with a good grade in this internship. So and we'll be talking about the DevOps session. I was thinking that we could do like a brief introductory of why the DevOps track was what you chose, but we can talk about that on Slack, so we not waste unnecessary time here. So today we'll just be taking, there won't be any coding per se, to just be like a live introduction, or like where practical scenarios of what DevOps is, how it is being used in our world today, like trying to like further break down the concepts that are going to be shown to you in this stage course content. So the title of this stage is Introduction to DevOps. And in this stage, what we're basically going to be doing is a good explanation of what DevOps is, how DevOps is done in practice, how DevOps has been able to streamline some processes, the benefits of DevOps, and integral part of what DevOps is to our development world today. Okay, so if we are going to go to our first slide, what was a brief definition of DevOps? DevOps is not just a set of tools or practices. It is actually a cultural shift that happened a few years back, and it emphasizes collaboration, communication, integration between development and operation teams. So it breaks down silos and promoted shared responsibilities throughout the software delivery lifecycle. So rather than just saying DevOps as probably just a term, or probably a method of development or something, DevOps is actually a bit wider than that. DevOps is all encompassing, and it's a cultural shift that was introduced to try and streamline the way development is being done. Previously, in the method of deployment and development practiced by large operations or even small scale companies trying to start up something, the 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 method of delivery was bureaucratic and rigid. So it allowed errors to persist even up to the point where in deployment these errors persisted, and it also allowed errors to go without notice. So when you are working on or creating a development and errors go unnoticed, by the time those errors begin to show face, it's something that could have caused a lot of damage in production workflow, which could lead to a loss a great amount of loss. So it could be loss in terms of downtime, where users cannot use your app. It could be loss in terms of financial loss, where you overpay or you overuse a particular thing where you are not meant to use it for that particular amount of period of time, or in cases where you have a development or a team that is developing an aspect of your production, but is not following standard procedure that has been set down. But due to the fact that there was no easy way to streamline and manage all of this process easily, it became a big issue, and DevOps is the solution to that. So DevOps aims to streamline the process of building, testing, and deploying software by implementing automation, feedback loops, and continuous improvement. So these three things, automation, feedback loops, and continuous improvement, are one of the core aspect of any DevOps practice. So by adopting DevOps practices, organizations can deliver software faster with higher quality and more reliably. So when we shift to a DevOps culture, a DevOps paradigm of development, it enables us to spot errors faster. It allows us have high reliability in whatever is being shipped to users, and it also aids in what ensuring that development and testing and deploying is what is very easy. In previous times, um, deployment and testing were like very different stages. So it could take days for a team that is working on testing to finish testing, and then they have to manually notify the team in charge of development before the team could perform the deployment action. So it was a very manual process, where moving from one step to another step in the development process was slow and buggy, in the sense that leaving everything to manual, while manual overview is appreciated and needed, but leaving every single thing to manual scrutiny allowed some mistakes that could have been spotted, allowed it to pass. So, but now with DevOps, there's automation in place. So automation ensures that an automatic evaluation is done immediately. So you don't have to wait after you finish a process. You don't have to wait, say, a day or two before you get the feedback of whatever results that particular development has done. Immediately your feedback is sent to you, and with your feedback you can immediately go back to your code and fix whatever caused a bad feedback to be sent, and start again the process of automation and feedback. So you have this loop here that ensures that the only piece of your code, or the only piece of your infrastructure that passes through the testing phase, is a piece of code or development that has been vetted and is sure that follows the correct procedure and standards. So when we integrate automation with continuous feedback, so when a developer pushes a code, for example, immediately the code can be tested for formats. So in Python, for example, the format is that when you have, let's say, a code block, like you use keywords like if or else, or when you define a function, the next line should be indented. So there might be cases of incorrect indentation, but because the developer is not going to be running the code in the development environment, it might not be a very easy thing to run whatever development you have made separately. It might be something that is part of a larger workflow, where it has to move to the deployment environment before this can be tested. So after developing your code and making these errors in indentation, and you do not spot it, you then push your code and move it to the deployment phase for testing. At that point in time, if it's a manual process, it takes until the testing is completed before an easy before a very minor issue like that, because an issue with formatting and indentation is an issue from the developer that should easily be spotted and fixed. But imagine wasting resources to move the code from development phase to testing phase, or even deployment phase, just to now realize that it is an issue with indentation that is causing the code to fail. So these are the kind of things. Then your changes have to be rolled back. The development has to then fix this indentation and then move it back to the deployment process. So this kind of process is not optimal, and it allows resources to get wasted. So that is what DevOps tries to do. It gives us ways to automate all of these steps, automate testing, automate deployment, automate even initial random meager checks for development to ensure that everything is acting as it should. So it is only when um, the automated actions for a particular stage has been passed, that is when a piece of code or a piece of production or a piece of development is moved to the next stage. Else, the continuous feedback loop ensures that whoever is in charge is immediately notified that okay, we have spotted an issue, and then you have to fix this. So that is basically what DevOps does to us. Okay, so this should not be here. Let me just take this here a bit. So the next thing is in DevOps. In DevOps, we have two major aspects of DevOps. The first part is the continuous integration aspect, and the next part is the continuous deployment or continuous delivery aspect. So the aspect of continuous integration and continuous delivery will be looked on in focus. That will be the major focus of the next stage, where you'll be shown even more deeper things about what CI/CD implies and how CI/CD is an aspect of DevOps and how it helps development. So, what is continuous integration? It is a development practice where developers regularly merge their code changes into a shared repository, usually several times a day. So each match triggers an automated build process, including compilation, unit testing, and code analysis. This is basically what I just explained. So that's the continuous integration part. So when a developer, most of us should be conversant with GitHub. So on GitHub, we can have a repository where thousands of developers or hundreds, maybe thousand might be an overestimation. Hundreds of developers, or even for open source projects. For open source projects, it's possible to have thousands of developers on the same project. So we might have a case where we can have a case where a lot of developers are working on the same project, and are making their each of them are making their different changes. Each of them are making their different changes to the code base. So if each merger had to be checked, if each merger had to be checked manually before compiling and testing and analyzing the code, it will take a lot of time to get the code that follows standard. Or imagine spotting an error after you finish compilation unit testing, and then the error was spotted in code analysis. You have to revert back to the first process of compilation and then let the developer know that he has to make some changes. But with continuous integration now, these processes are automated. So immediately these changes are made to the repository, a set of actions that either builds it, tests it for things like indentation, tests for the spaces, makes unit tests of each function to see if each function provides the correct response, and code analysis. All of these things are automated, and immediately a push is done, it is triggered. And once it is triggered, the continuous feedback loop is also triggered. So if at any point of this automated process a step is failing, the developer is immediately notified that at this point your step has failed, and then due to this failure you have to probably rearrange your code base, or you have to work on your code base further. So the primary goal of the continuous integration is to detect integrations early in the development lifecycle, as I've said. So you address all of these issues quickly and ensure that at every point in time, your code quality is always top notch and has not been tampered with. Um, so in the next slide, so it's just continuing on continuous integration. By automating these processes, with enables teams, you deliver more quickly, you reduce manual errors, and you foster collaboration. So a developer does not have to wait until, imagine in a scenario where two people are working on the same file, and one developer has to have finished his own aspect of development before another developer can pick up the other part he wants to work on. So if this whole process of building, automating, and testing that the first developer has done the right thing is manual, it will take a lot of time before the other developer gets unblocked to work on his tasks. But once all of this is automated, the automated processes that can even immediately alert the other developer that it is time for him to pick up because the previous developer has finished with his workflow and everything has passed successfully. So some key components include version control. So a very, very key aspect of continuous integration is version control, which is what GitHub falls into. So more explanation on what version control is, the type of version control systems that we have, and what they do in terms of keeping file history will be talked about in this stage and also in the next stage. So Git itself, not even GitHub, because we have a lot of platforms aside from GitHub that provide the same function. But Git itself is the major component that provides the version control system. So platforms like GitHub, GitLab, Gitbucket, and the likes, they are built on the foundation of what Git itself provides. So Git is the major tool that is for version control system, and it is the most popular. It is not the only, but it is the most popular because it has been widely used and has shown to serve developers as fast and quickly as possible. And then we have continuous integration servers, because when you want to automate this process, now that it is not manual, there has to be a location where the you can abstract it like a computer on the cloud, where this computer is going to be hosting the code that does the checking of the code. So there has to be a server somewhere that holds this environment where the automation is going to be performed. So this automation also needs its own servers, and one of the two very popular server providers are Jenkins and Travis CI. So Jenkins and Travis CI, hopefully in the next live coding session, we can try to show what Travis CI is, even if it's not in this live coding session, because in the next live coding session, we are going to be focusing on CI/CD itself as a topic, where we'll go deeper into all of these tools and see how some of these tools work. And two other tools are build automation tools and automated testing frameworks. So for example, for Python, an automated testing framework is PyTest. So when you have something like PyTest, you can write all of the tests you want for your code, and if any test failed, immediately that build action is also failing because the test has failed. So continuous integration in some way, it helps us streamline development workflow, encourages best practice as writing unit tests and maintaining a stable code base, and it also accelerates the feedback loop between development and testing. So when we move to the next one, continuous delivery. So continuous delivery is an extension of continuous integration, but this aspect is focusing on automating the software delivery process. So after you are done with your continuous integration and you are sure that immediately a new change is made, it is automatically integrated to the previous code base. We then take it a step further where we automatically deploy or make this new change easily available to whoever the end user is. So this is what enables a lot of companies to be able to make updates in real time. So that is why when you see some websites are down in 10, 15 minutes, an hour most times, they are done with all of these things because they don't have to manually go through the process of initiating the build and initiating the deployment. All of these steps have been succinctly and explicitly defined, and then when any change is made, it is immediately. That's why using things like WhatsApp, you can see that you might know most times if the kind of update that WhatsApp wants to make is not actually a major update, you can close the app around 6 p.m. and open up the app again around 7 p.m. and you see that there are some changes that have been integrated. For example, like I think around 2 days ago, we started noticing something around Meta AI, where you can tag Meta's AI in any of your chats and ask it questions directly from WhatsApp. I did not have to download a new app from Play Store for this update to get integrated into my device. All I just did was open up the app and I saw that okay, these particular changes have been made. So that is what continuous delivery is. It ensures that you are able to effectively and quickly get out changes that you have made in your environment. You are able to get them out there. And the faster these changes get out there, the more you are able to serve your customers and make sure that your customers continue to use your product. Because imagine a lot of customers are complaining about, let's say, the size of a text box for a text box. Let's say you have a chat app, and in your chat app, customers are complaining that the text box where they type in whatever message they want to send to people is too small. Something like that is a kind of change that is made that should be able to be done almost immediately. And the only way you can always do this almost immediately without having to stop all your users, because if you don't have automated processing step, all your users have to be stopped from using the app before you can make a change, because there will be a downtime where you have to tell your users, okay, we are performing some maintenance, and then you make this change, and then it manually goes through it of this step from a manual integration before it gets to the final user, before you then take your app out of downtime. But with with continuous delivery, you can ensure that your current users don't have to even know that this change is coming. Once you pick it up and you see that it's a very, very easy feature that you can include, you add it to the automated process, and once the code has passed, it gets delivered automatically, and it might just be on a refresh. They will just get delivered a new text box, and they will notice that, okay, this particular change has been made. So these are the kind of things that DevOps, the core precept and core principles of DevOps gives to us. So the goal of continuous delivery is to ensure that the software can be released to production at any time with minimal manual intervention. So key emphasis on minimal manual intervention. So we don't want a lot of people to keep being the ones to initiate this deployment or having particular access to the deployment environment. The deployment environment is should be sacred, and only expected code should get into it. So as long as the unexpected code gets into it, there should be a feedback loop that will immediately reject that particular change and say that you have to pass through a series of automated processes that have been fact checked before you get to the deployment environment. And it emphasizes frequent, reliable, and predictable deployment. So when you have a CD step, you rarely have to think about what is causing a deployment to fail, because even in the event that a deployment fails, then it must be a major issue, because continuous delivery ensures that your deployment is seamless and streamlined. So it incorporates the everything that we do in the CI, automated testing, for deployment orchestration. So apart from the part of testing the code itself, then the aspect of where the code is going to be hosted, the environment that will host the code. Because, for example, if anyone here has probably any experience with writing a, a mini web app, let's say with Flask or Fast API, you know that after you finish writing your code, you have to run your code, even for Python, or and even if it's not a web app, you have to like have an environment, the Python environment if you are using Python, or Node.js environment if you are using Node.js. Node.js is also for TypeScript and the likes, where you have to perform some commands that will now make all of the lines of code you have written come to life and start performing their actions. So there has to be this environment somewhere, and that's the deployment environment. And then provisioning all of these environments, making sure that it is in the correct state of mind, ensuring that all of these are as expected, is what continuous delivery does. So key components includes deployment automation tools. So deployment automation tools, these are the most popular example: Ansible, Puppet, and Chef. Containerization platforms, and in this aspect of DevOps, what we'll be focusing on is Docker. So Kubernetes is a step further than Docker, and this will, with enough knowledge of Docker, then interacting with Kubernetes should not be an issue, because Docker is the containerization platform or the knowledge that you need before you can start interacting with Kubernetes. Then this is probably one of the most popular tool in DevOps. It's called Terraform, and it is an infrastructure as a code tool. So what Terraform does is it enables us to use declarative statements to spin up infrastructure. I don't know, we'll see talk in this internship for our live for our platform. The cloud platform we focus on is Azure. But Terraform is a way. You will see that there are many ways to deploy resources on the cloud. You can use the cloud console. Most of them provide a command line interface tool that you can use, and you can use JSON even on the console. So the major two ways are either you use the cloud console provided by the cloud provider, or you use the tool that is provided by that provider for you to work, the command line tool. But with Terraform is not limited to just one provider. With Terraform, you can deploy AWS services, AWS components. You can deploy components from Azure. You can deploy components from GCP. You can deploy components from, as long as the cloud provider has been fully registered to work with Terraform, you just need to write declarative statements. So in Terraform, it's different from conditional, where you say, okay, if a length is equals to this, this has been added now, but mostly we deal with declarative statements where we say, okay, give me a Kubernetes pod, a Kubernetes engine, and in this Kubernetes engine, I want it to have two pods, and each of these pods will contain two containers each. So you write all of this declaratively, and immediately, as long as your declarative statements are valid Terraform code and you have enough access, you can use that to spin up an infrastructure that gets spinned up immediately. So moving on to the next slide. So we just want to talk about some real world examples. So Netflix is probably one of the biggest streaming platform, and they're a prime example of how DevOps enables because they use tools such as Jenkins. So Jenkins is their CI. They use Spinnaker for deployment automation to renew new features. So it is not going to be a good picture for Netflix. Anytime they want to make an update, for them to tell millions, billions of users that they have a downtime, seeing how important they are to most people because people keep streaming online. So they are one of the largest employers of DevOps practices where they automate most of their changes, and it's where you see that these guys have a downtime. AWS itself, AWS is Amazon Web Services, and this is one of the biggest cloud providers that provide a lot of cloud infrastructure tools that a lot of users are using to even now provide websites or other kind of services to the masses. AWS itself gives us a lot of ways, rather than just implementing DevOps for itself, it also gives companies and organizations means to enable them to practice DevOps. So it provides a lot of infrastructure as a code tools, Terraform and AWS Cloud Formation to manage resources programmatically. So Amazon itself uses DevOps practices to even provide tools to users that can also use those tools to also implement DevOps practices. So a lot of users, because Etsy is also an online marketplace where they embrace DevOps. So one of the very, very use case where DevOps is also very easy in something like Etsy, where we have a marketplace online, like a retail shopping store online. You have a lot of goods coming in from a lot of different users, or a lot of new things that are added to stock. So imagine you always have to take a downtime anytime you need to add a new feature, or you need to add a new stock, or you need to add a new section for a new category and stuff like that. It will allow you to waste a lot of resources, and even people won't rely on your services because you have a lot of downtime. So these platforms like this, they make use of DevOps and continuous integration and delivery to ensure that they always have their deployments ready for people to use. So in the last series, before we end this, we'll be talking about some continuous integration tools. So the first one is Jenkins. It's used for building, testing, and deploying software. We also have Travis CI and Circle CI. So these are like the most popular. There are a lot out there with more coming on, trying to give a new aspect of what the previous are not giving. But the major three that we have currently out there are these: Jenkins, Travis CI, and Circle CI. For management, we have Ansible, Chef, and Puppet. So this one is used for management after a deployment has been made, to be able to oversee all of your workflow processes. Okay, this pipeline, when did this pipeline end? What caused this pipeline to fail? How is the pod? How are my logs going, and all of this kind of stuff. Another very important tool is containerization. So from all of these tools, another continuous integration tool, which was not listed here, is Git Action, and that is what we'll probably be having the most interaction with. So this stage is going to introduce Git Action, and then your next stage, you will even further go deeper into Git Action. Because of this, most of these tools are not free. They are paid tools, but they are very easy to use. But they all use the same pattern and terminology, and they are all written using YAML. So most times in this aspect, DevOps and cloud aspect, what we use mostly for infrastructure is YAML. After writing the code in whatever language, YAML is like the standardized language that is used for writing most of this deployment stuff. So we use Git Action for our continuous integration. For our containerization, Docker is going to be the go-to. Docker is very popular. It's a containerization tool, and the stage D is going to be talking majorly about containerization with Docker, where we try and explain what Docker is, how Docker works, and so you can understand what it means to have a set of code always remain the same, even when it is going through different multiple deployment platforms. Another tool we have is monitoring tools, things like Prometheus and Datadog. These are actually fairly they are more data engineering oriented than DevOps itself, but they are tools that are used, especially in a stage where you have to ensure that you keep monitoring the process of how your data is going from the source to the final pipeline. And then we have the version control tool. So Git is the major one. As I said, there are other version control tools that you also be introduced to, but Git is our go-to for this internship, and we'll be using GitHub platform to implement with Git. So our continuous integration is going to be something that was provided by GitHub, which is going to be Git Actions, and you can see how you can use Git Actions to write a lot of automated tests, automated building, and integrating things like Git Action with Docker for a lot of different practices. So with that, we have come to the end of today's live coding session. It's just a brief introduction to what DevOps is, because for this part of the course, actually, there's not really much coding. It is just a lot of ingraining of concepts, how deployment works, the difference between monolithic systems and microservice orchestrator. It is because of DevOps that we have things like microservices, and the microservices is heavily dependent on container orchestration and organization and stuff like that. But in our next live coding session, we'll try to at least introduce ourselves to some of these tools. To not be an in-depth introduction, just be a basic introduction. We'll introduce ourselves to what Docker is, see Docker in action, we'll introduce ourselves to Git action, also see what it actually means to have a Git action, because your tag along project for this stage is based on Git action for this stage and the next stage actually. And then we also look at other tools also, that what other tools, things like Terraform, what Terraform is. But the last aspect of this the last aspect of this internship is going to focus more on Terraform, and then we'll look at Azure Cloud Platform and what all of this provide for us. So it's going to be a very wonderful world where a lot of new concepts is going to be taught, and one has to be able to read vast and read afar to let some of these concepts become ingrained into so you can even practice this, because you don't even have to work in a large organization for you to practice all of this, because in the long run you see that it gives a lot of benefit when you start practicing DevOps methodology from the get-go rather than doing a monolithic approach. So in our next live coding session, by that stage, I believe everyone should have gotten to a point of knowing the difference between what a monolithic approach is and a containerization approach. And we'll try to show a brief demo around this before we then showcase some tools that we'll be using that are being used in DevOps generally, and the one that we'll be using in this internship. So with that, that's the end of this live coding session. Is there any question, or I can take a question or two? Or if there's no question, or maybe a question pops up later, you can drop it on the Slack channel, and I'll be ever available to attend to these questions. Okay. Ayodeji, you were saying something?
Yeah, sir, good afternoon, everybody.
Yeah, good
I
afternoon.
just wanted to confirm, I know we are to do like four coding session for this stage, right? So I just
Yes,
wanted to
for
confirm at which stage are we going to start doing the labs?
the labs.
Yes, please.
The coding session does not actually try and solve what the lab entails, actually. So the coding session is just a series of sessions that try to go through each aspect of the course and just try to explain it further. So the next coding session might not be on Git action, it might be on Docker and what Docker is to microservice architecture, because microservice architecture is also spoken about in this course. But by the live coding session, we should have spoken about Git action. But what I'm just trying to say is you don't necessarily have to wait for the live coding session before you can start trying to understand what the tag along lab is. You can just start going through your course content. The faster you finish your course content, and the course content is actually a little bit voluminous. It was something that I also took when I participated in this internship. So my advice is, if you might see that the course content, because you need the course content to take the quiz, but you might not necessarily need everything about the course content to go to the lab. So you can just visit the tag along lab, because we redirect you to a GitHub page. With the GitHub page, with what is expected from you, because it is just it's actually a very, very simple lab with just you following instructions to the letter, and then you are good to go. So we just tell you, okay, at this point, you have to edit this, you have to do this on GitHub. And then when you are done, you provide us with a link to your GitHub page. So you don't necessarily have to wait for the live coding session to get to the point at which you can begin to submit your lab. As a tip, also, I would advise that, okay, before the next live coding session or the third one, you could have gone through the instructions that we expect you to follow for the tag along lab. And then if you have any questions on it, you can relay that to me during the live coding session or even on the Slack channel, where I will try to expand further without necessarily answering the without necessarily exposing the answer of what needs to be done for the tag along. So, but for the course content, it's quite voluminous. You just have to try and we have a lot of tools that helps in reading these days. I myself am someone where I like to skim through a lot before trying to go in depth. So you can try to just skim through all of this content as fast as you can, and then go over it again, because I think there are 2 weeks. This session, this stage is going to continue for the whole of next week, and then till Wednesday upper week. So you have a lot of time to just try and cover the course content as fast as you can, so you can go through you can do the quiz, and then also finish the tag along lab. But just to finalize, you don't necessarily have to wait for the live coding session before you can start your tag along lab.
That's noted. Thank you very much.
Yeah, no problem. All right, guys. So, with that, we have come to the end of today's live coding session. As usual, you can use the Slack channel to voice your thoughts, ask questions, any question at all, as long as it's related to DevOps. As long as it's related to DevOps or anything, just try and ask on Slack, and I or even your fellow colleagues will be able to hear you out. So, bye bye for now, and see you guys next week.